Okay, so here is the review for the rational test that is tomorrow. The first question, suppose that x and y vary inversely. So inversely, that's your keyword right there, means you're going to be dividing. So I'm going to be using y equals k over x, and y is 6 when x is 3. We want to write a function, so that's going to be an answer that models that inverse variation, and then find y when your x is 10. So first thing, I'm going to take these numbers and plug them in. So y equals, well, your y is 6. 6 equals k over 3. Well, when I'm solving for k, I'm going to multiply by 3 on both sides. So k equals 18. So my function, I'm going to take that k, plug it back in, and now I have my function, y equals 18 over x. So there's your first part. The second part, find y when x is 10. So I'm going to use this function that I have, and I'm going to plug in 10 for x. So this reduces to 9/5 or 1.8. Either of those will be fine as an answer. Alright, second equation. Suppose that y varies directly. So that's your keyword. We're going to multiply by k with x, and inversely, so inversely means I'm going to divide by z. Now, they give me the numbers so that I can figure out what k is. So y is 25, x is 35, and z is 7. Well, 35 divided by 7 is 5. So 25 equals 5k divided by 5. So k equals 5. So again, for my function, I'm going to plug it back into this form. And there is my function. So that's the equation. Then the second part, find y when x is 12 and z is 4. So y equals 5 times 12 divided by 4. Okay, well, 12 divided by 4 is 3. 5 times 3 is 15. So there's your second answer. Alright, number 3, describe the combined variation that is modeled by the equation y equals w over 2x squared. Well, since the w is on top, that means it's a direct variation. So I have y varies directly with that variable, so with w. And since we're dividing by the x squared, it's inversely with x squared. You can either write inversely with x squared or inversely with the square of x. Either of those will give you the same answer. Alright, so that's your description. That's what I want when it asks a question like that. Alright, 4, simplify the rational expression stating the restrictions. So the very first thing that you need to do on this is to factor. So we're going to look what multiplies to be negative 32 but adds to be negative 4. That would be negative 8 and positive 4. And the denominator is already as simple as it can be. So from this, my restriction, p cannot be. Well, what makes this denominator 0? That would be negative 4. So p cannot be negative 4. Now I'm going to look and see, do I have any common factors I can cancel? Well, p plus 4 is cancel. So all I'm left with is p minus 8 with my restriction as negative 4. There's our answer. Alright, so same thing on number 5. The first thing we're going to do is factor. So what multiplies to be 24 but adds to be 11? Well, oops, I wrote the wrong thing. 8 and 3. 8 times 3 is 24, and 8 plus 3 is 11. On the denominator, needs to multiply to be negative 24 and add to be negative 5. So negative 8 and positive 3. Alright, write our restrictions. Q cannot be positive 8 for the first part and negative 3 for the second one. And now let's cancel our common factors. So I'm left with Q plus 8 divided by Q minus 8. And nothing else cancels, so that's going to be our answer. Number 6. When we are multiplying numbers like this, you multiply across the top. So 4 times 2 is 8, and since these are different letters, I'm going to leave them as they are. So a to the 5th b squared. 7 times 2 is 14, a to the 4th b to the 4th. Now I'm going to reduce. Reduce 8 over 14 becomes 4 over 7. If I have 5 a's on top, 4 on bottom, I have 1 left over on top when I cancel. 2 b's on top, 4 b's on bottom, so I have 2 b's left. Alright, so that's going to be our simplest form, and then our restrictions, since we have 2 variables, what makes this factor 7b to the 4th equal 0? Well, the only thing I can multiply 7 by to get 0 is 0. So both a and b cannot be 0. Alright, number 7. Again, the first thing I'm going to do is factor. So I have c plus 1 over c minus 5 divided by c minus 2 over, if I factor this, what multiplies to be 10 but adds to be negative 7, c minus 5 and c minus 2. Alright, remember when you divide by fractions, you have to multiply by the reciprocal. So I'm going to flip the second one and multiply. So c plus 1 over c minus 5 times, now I'm going to write the reciprocal. Okay, now let's cancel things. Oh, let's write our restrictions first. C cannot be 5 from this first one, 2 from the second one, and I need to look back at the original denominators, and those are both the same as what I already had, so that's fine. So canceling, I cancel c minus 5s and the c minus 2s, so all that's left is c plus 1, so there's our answer. Okay, number 8, I'm going to go ahead and do on notebook paper. I start off with 7 over a plus 8 plus 7 over a squared minus 64. Alright, so as always, we're going to factor first. So the only thing I can factor is the denominator of the second fraction. So I end up with a plus 8 and a minus 8. Alright, now in order to add fractions, you have to have a common denominator. So if I look to see, the only thing they have in common is this a plus 8. That means this first fraction is missing this a minus 8. So that's what I'm going to multiply the first one by. Top and bottom, so that we're not changing the actual problem. So this is 7 times a minus 8. And if I go ahead and combine my fractions, I'm going to have plus 7 all over a minus 8 times a plus 8. Alright, when I distribute here, I have 7a minus 56 plus 7 over a minus 8a plus 8. Alright, if we go ahead and combine our numbers, negative 56 plus 7, I get negative 49. So this is my final answer. I could go ahead and factor out a 7 if you want. If you don't, it's not that big of a deal. I would not count off if you left it as 7a minus 49. And my restrictions are 8 and negative 8, because that's what makes my denominator 0. So, again, it can be this form or this form, and it will be just fine. Alright, number 9. I have d squared minus 90 plus 20 divided by d squared minus 3d minus 10 minus d squared minus 2d minus 8 divided by d squared plus 4d minus 32. So I'm going to go ahead and factor top and bottom of everything. So I get d minus 4 and d minus 5 over d minus, or plus 2 and d minus 5 minus we get d minus 4 and d plus 2 divided by d minus 4 and d plus 8. So hopefully you know how to factor by now and get all of those. If we go ahead from here and write our restrictions, I have d cannot be negative 2, d cannot be 5, d cannot be 4, and d cannot be negative 8. Alright, now let's cancel out our common factors. So now I'm left with d minus 4 over d plus 2 minus d plus 2 times d plus 8. Now if I refer back to number 8, originally they had a factor in common, so all I had to do is multiply the factors they didn't have. Well, in this case, they don't have a factor in common. They're both different. So I'm going to multiply by the factors they do not have, so the other one. So this one now has a d plus 8, so this one now needs the d plus 2. Alright, once we get to this part, I'm going to just FOIL the top. So d squared plus 8d minus 40 minus 32 over d plus 2, d plus 8 minus d squared, and it's going to be minus all of that, plus 2d plus 2d plus 4 over d plus 2, d plus 8. Alright, since my denominator is the same, I can go ahead and simplify from here. Well, if I look at this, this is 40. Look at this, this is 40. Okay, we are going to just subtract each of these. So d squared minus d squared is 0. 4d minus 4d is 0. Negative 32 minus 4 is negative 36. And then my denominator is the same. So this and that are your answers. Alright, number 10. When you have a rational equal to a rational and we're solving, we're going to cross multiply. So I'm going to have x minus 2 times x plus 3 equals x plus 4, x minus 4. Once we get here, we need to FOIL both sides. So I'm going to have x squared plus 3x minus 2x minus 6 equals x squared minus 4x plus 4x minus 16. If I go ahead and combine my like terms on both sides, I have x squared plus x minus 6 equals x squared minus 16. Alright, now I want to move everything to be grouped together, so I'm going to subtract x squared. Well, they end up canceling on both sides. So now I have x minus 6 equals negative 16. So now when I solve for x, add 6, so I get x equals negative 10. Now, it says check your solutions. Well, the way we can check our solutions is look at our restrictions from the beginning. So from the beginning, x cannot be negative 4 or negative 3. Is that one of our restrictions? No, so this is our answer. Alright, number 11. I have a divided by a squared minus 36 plus 2 over a minus 6 equals 1 over a plus 6. Now, if I have two rationals being added together equal to another rational, I'm going to multiply by its least common denominator. So my least common denominator, if I factor this out, I have a plus 6 and a minus 6. This is my least common denominator. So I'm going to multiply this whole thing by a plus 6, a minus 6, all over 1, so that we can write it as a fraction. So when I distributed this to each piece, I have a times a plus 6 times a minus 6 all over a plus 6, a minus 6, plus 2 times a plus 6, a minus 6 over a minus 6, equals 1 times a plus 6, a minus 6 over a plus 6. So I know it still looks a little bit complicated, but if we cancel everything that's in common, I'm left with a plus 2 times a plus 6 equals a minus 6. Now this is a much simpler problem to solve. So I'm going to have a plus 2a plus 12 equals a minus 6. That gives me 3a plus 12 equals a minus 6. I'm just combining all my like terms. So if we get all the a's together, if I subtract a, I have 2a plus 12 equals negative 6. Subtract negative 12, 2a equals negative 18. Divide by 2, so I get a equals negative 9. So again, if I write the restrictions from the denominator, I have a cannot be negative 6 or positive 6. So that's my checking, so this is an answer. Number 12 is one that we did exactly like this on the notes. So here, the least common denominator is x. So I'm going to multiply everything by x. And I can put it over 1 if that helps you. So x times x is x squared plus 6x over x equals negative 5x. So all I did was distribute that to everything. Okay, these x's cancel. So I'm left with x squared plus 6 equals negative 5x. Well, since there's just one of each term, I need to move everything together to make equal 0. So I'm left with x squared plus 5x plus 6 equals 0. Now from this, you're going to factor. Multiplies to be 6, adds to be 5, so 2 and 3. And since we're solving, I need the answers. So set that equal to 0. So I'm going to get x equals negative 2 and x equals negative 3. Now again, let's go back and look at what our restrictions are. From the beginning, the only thing that makes that 0 is 0 itself. So both of these are our answers. Alright, 13. We have 2 over x plus 2. There are no holes because nothing cancels. The roots, if I try to set 2 equal to 0, that can't happen, so there are no roots. Vertical asymptotes makes the bottom 0, so x equals negative 2. Tangent C, there is no even root or exponent on the top. Togetherness, there is no even factor on the bottom. Fabio, Botno, ECC, since there's only an x on the bottom and not on top, it's Fabio. So y equals 0. And the y-intercept, if I plug in 0, for the x's, I have 2 over 2, which is 1. So, let's graph. There are no roots. Vertical asymptote at negative 2. Horizontal asymptote at 0. And a y-intercept at 1. Alright, so this really doesn't give you a lot, but because there are no roots, I know that this graph cannot cross the x-axis. So it has to be above for that point to connect. And since there's no togetherness, the rest of it needs to be in that little piece. So remember, whenever you have a vertical asymptote, you have to have a piece on every side of it. Just the vertical. The horizontal doesn't matter. Okay. 14, if we factor, multiplies to be negative, or multiplies to be 12, but adds to be negative 7. So negative 4 and negative 3. And then x plus 1 and x minus 1. Holes, there are no common factors, so there are no holes. The roots, what makes the top 0, 4 and 3. Vertical asymptotes, what makes the denominator 0, so negative 1 and 1. Tangent C, neither of those factors are squared, so there is no tangent C, so that means it goes straight through the roots. Togetherness, neither of those factors on the bottom have a squared. Fabio, Botno, ECC, this one's ECC. If we look at this factor, there's 2 x's up here. If we look at the original, they're both x squared. If I divide the coefficients, I get 1. X-intercept, I can plug 0 in for the x in either of those. I'm going to choose to do it in this, so that covers both of these, all of these x's up, so I'm left with 12 over negative 1, so negative 12. Alright, if we graph, I have it 3 and 4, negative 1, and positive 1. And then at negative 12, I'm just going to pretend this is negative 12, since it kind of goes off the graph anyways. Let's see, I think that's all I have. Okay. Now, for this negative 12, I know that something has to happen. It can go up, go down, it can be a parabola opening up or a parabola opening down. Well, since these are my only two roots, the only option for this is to be a parabola opening down. Any other way would make it cross the x-axis again, and we can't let that happen because it can only cross here. Oh, I forgot the horizontal. Okay. Now, since there's no togetherness, I know that this has to go up, because it can't be together with this piece here. Well, then it also goes through the root. Well, it has to go through this one as well, so it's just going to go through and kind of hug that asymptote again. So again, since there's no togetherness, it can't be down here, it has to be in this piece up here. Alright, number 15, again, factor first. So I have x minus 4 times x plus 2 over x minus 3 times x plus 2. Alright, in this case we have a common factor, so let's cancel. So that means that root is at what makes the 0, negative 2. Then I need to find the other piece, the x or the y value, by taking negative 2 and plugging in whatever's left. So I have negative 2 minus 4 over negative 2 minus 3. So it's negative 6 over negative 5, which is positive 6/5. Alright, now from everything else I'm looking at just this piece. So my root is at 4. Vertical asymptote is at 3. No tangency or togetherness, because neither of those factors are squared. Each DC, because they both have x's. So y equals 1, because those are the coefficients, 1 and 1. Y-intercept 0. If I plug in 0 for those x's, I get 4/3. Alright, so if we graph all of this, at negative 2, 6/5. 6/5 is a little over 1. It's a hole, so you're going to have an open circle. Alright, at 4, 0, have a root. X equals 3, I have an asymptote. Y equals 1, I have an asymptote. And 0, 4/3. So again, that's a little over 1 as well. Well, since these pieces are both to the left of this asymptote, I know they have to connect. And it can't cross the x-axis again, so it's going to go up. Well, and then there's no togetherness, so this one is going to go down. Alright, on 16, give an example of a rational function that has a vertical asymptote at x equals 4. So vertical asymptote, we're looking at the denominator. So as long as on the denominator you have something x minus 4, it doesn't matter what's on top. So this is just an example. And it needs to be a function, so f of x equals. Alright, 17, give an example of a rational function that has a vertical asymptote at x equals 2. So that's my denominator. A horizontal asymptote at 2/3. And a or an x-intercept at negative 2, 0. So that would be x plus 2. The root is on the numerator. Okay, this 2/3 means it's each DC, and your coefficient needs to be 2/3. So I'm just going to put these in parentheses and make that 2/3. These are your most basic ones. You could make them more complicated than this, but this satisfies all of those conditions. So those are the examples. Alright, hopefully this was very helpful. If you have any questions, please come see me during Hawk Time tomorrow if you get a chance, and good luck studying!